Hi, welcome back. I'm in chapter 7.3, Relations between Distributed Load, Shear and Moment, which is from page 373 of the textbook itself. Yeah. So, this topic will be actually sort of like a summary topic to 7.2. It's more of like to check your answer in 7.2, whether the graph that you've plotted is correct or not. Yeah. So this is like something like a to check the answer, like a shortcut method. Yeah. Consider beam AD subjected to an arbitrary load. So we have a beam AD here, okay, subjected to load, yeah, and concentrated forces and moment. So you have this load. So this load need to be translated into two graphs, right? That's what we did in the last class. The Vx graph and the moment X graph, yeah. So distributed load is assumed positive when loading is again it's acting downward. So in this part C, we can actually concentrate this, yeah. We can actually concentrate this in two parts, right? Okay, so let's look at this. Okay, this is a triangle and this is a rectangle. You can actually distribute this to the middle part and this trapezium to two parts and one part rectangle. Okay, I'm going to show this the next slide, next few slides. Yeah, but before that, rather than reading the slides itself, I will just give you a summary of the what they are trying to say here. Yeah, this will be similar to the textbook itself. So I'll just shift you to the textbook because textbook is a bit clearer. Okay, so let's look at the textbook. Can you see this blue box down here? Yeah, the blue box down here says dv over dx is wx. So slope of shear is equals to the distributed loading. Okay, look at this. Slope of the shear diagram is a negative of distributed of load intensity. Next, slope of shear diagram is the shear moment diagram. And the change in shear diagram is the area under the shear diagram. Change in moment will be the area under shear diagram. I know it sounds very confusing, yeah? Okay, but let me just go through the boxes with you. Can you see this blue box in your textbook? And then there's another box, another box. So we have total in 4 formulas in the textbook. Okay, I'm going to explain to you shortly. Yeah, okay, let's look at the slides itself. Okay, look at this. In order to scribble, I'm actually bringing you to the Word file. Yeah, okay, so let's look at this. Yeah, okay, what did the box say? The box said change in shear will be the area under the loading curve. Okay, and the slope of moment will be the shear. Okay, so let's get back to this. Okay, let's look at this. So if you see here, there is no loading here, right? There's nothing here. Okay, nothing here, and there is a loading here, 4 kilonewton, and this is an evenly distributed loading. Okay, now look at these. If I were to translate this into graphical form, okay, graphical form. Okay, just observe this. Now, when you need the eraser doesn't come out, isn't it? 1 second. Hiya, what happened to the eraser today? Okay, let me just erase this. Get back to the pen. Okay, let's look at the graph first. Let me just make you understand. What does it mean by x? X order 0. X order 0 is actually equivalent to 1. So if you plot a graph, yeah, x power of 0, there will be only a constant line, either like that or whatever, just a constant line. Whereas x power of 1, your graph will be plotted either this way, yeah, if it's a slope, positive slope, or this way, right? So this is x order 1, yeah, x power of 1. Okay, because if this graph, it will look like what? Y equals to mx plus c. So see, x is power of 1. Okay, and then if we have x power of 2, so the graph will be slope power of 2, either that way, this way, or whatever, just power of 2. And then you have x power of 3, then you have a graph of x power of 3. Okay, so this is the order of x. So let me just explain to you. Yeah, let me just show you here a shortcut method here. Okay, erase this. You understood the earlier one. Let's go here. Okay, let's look at this. This is x order 0, right? Because it's a flat line. It's a flat line. X order 0, right? So if you plot from this load to the Vx graph, this would be x order 1. And from here, if you move to this segment, it would be x order 2. That's how we add up. Okay, so let's look at this, the first part of the graph. Yeah, there is no loading here, there's no loading here, there's nothing here. So if nothing here, here will be something, right? So this would be x power of 0, and the next one here, down here, would be x power of 1. It increases, yeah, there's nothing there, this would be x power of 0. Okay, so if you look here, okay, if you look at this area, there's no loading here, but there is something which is 2 pointing downwards. So that's the reason why this graph starts from -2. Okay, so nothing in between, just a flat line. Right up to B. When it comes to B, what happens? It hikes 10. So from -2, it hiked 10 means it had to reach 8. Can you understand? So it reaches 8. Yeah, it reaches 8. And then there is an evenly distributed loading here, which is 4 for the next 2 meters. And the area under this would be 4 times 2. 8 pointing down. 8 pointing down. So what will happen? 8 will move in an x order 1, 8 units pointing down. So it will achieve 0. Okay, that's the reason you see here W, the negative constant, it will be what? It will be a negative constant, a negative constant slope. The W will be the slope. The W will be the slope. So here, there's no loading, 0 loading, 0, nothing. So what will the slope be? 0. Yeah, which is x order 0. Okay. Okay. So now, next, let's move on to the second part. Okay, so let's erase this. Yeah, because if it's too messy, it's very difficult to understand, isn't it? Huh? Okay, let me just repeat this whole thing. Yeah, there's some part I can't erase. Not sure why. Okay, we are done. It's clean sheet. Okay, now let's look at this. So from 0, if you look here, there is no moment there. Yeah, no moment there. It means it will start from 0 in a moment graph. And there's no moment here. So which means it will end at 0. Okay? Okay. Now remember from the previous lesson when we calculated, we know that when the graph intersect at 0, it will be a maximum. Yeah, a maximum point either in the positive side or the negative side for the moment graph. Okay? So, assuming that we don't know that it's going to be this blue line here. Okay, let's look at this. This will be x order 0. So, this is x order 0. You're moving to here. It will be x order 1. Okay, and if you look here, it is what? -2 multiply 4. The distance is 4. -2 multiply 4 will be -8. So, from 0, it will come down to -8. Okay. Now, since that this is a negative constant, which means the slope will also be a negative constant. Okay. Now, let's do the second part then. Okay. The second part will be in the positive, right? But positive decreasing. What is positive decreasing? This area is actually in positive area, but the slope is actually decreasing, going down, right? The value, isn't it? It's going down from 8, it's going down to 0. So decreasing, yeah? So what will this be? The slope will be positive decreasing. Okay? Positive decreasing. What is positive decreasing? Okay, I'll come back to that. Before that, half times base times height. So what will this value be? Half times 8 times 6. So what do you have here? 4 times 2, 24. Sorry. Okay, so we have 8. Sorry, it's not 6. Half times 8 times 2. Sorry. Half times 8 times 2. Half times 8 times 2. Yeah, so it will be 8 unit. So you are actually at negative 8 and you will hike positive 8. Yeah, ending with 0. So you'll end up achieving 0.0. Okay, that's how it works. And this is positive. Yeah, this is positive decreasing. So therefore, it will be positive going up and the slope will decrease. Okay, what does it mean by slope decrease? So this is maths lesson, isn't it? Okay, look at the slope here and the slope here. Okay, this is very steep, isn't it? Yeah, very steep. Yeah, this is actually sort of like decreasing. The slope is becoming a plateau, right? So the value is decreasing, it becoming a flat line here. That's the meaning of decreasing. Okay, increasing means this is almost 0. Yeah, it's becoming steeper and steeper and steeper. So that is this means it is increasing. Okay, so that is the decrease and the increase. Okay, so we have done this part. In order for us to see, yeah, to just check our work, yeah, you need to check your work. Okay, otherwise it's very difficult, isn't it? To know whether what you're doing is correct or not. Yeah, so you can actually use the previous lesson, which is the equation method, yeah, to check your work. That is one option. Okay, let me just solve the second part. The second part of the question. It's a bit tougher because you know why? The slope is even. Yeah, because there is a slope. Okay, now let's look at this. This is in feet. Yeah, just ignore your textbook in SI. So I'm just showing you an example, but apparently my textbook is actually not in SI, the online version. Yeah, okay. Now let's look at this linear line here. So this linear line means this order is actually x1. So therefore the v graph, yeah, vx graph will be in order 2. And the mx graph will be in the order of 3. Yeah, that's how it goes. Yeah, the order will be increasing. Okay, let's look at the hint here. We have 240 pointing upwards, so it will start 200 positive, 240 positive. Yeah, because it's pointing upward, right? Okay, and you see the end here 480, so you know that it will go as low as 480 or whatever point, but it need to hike 480 units in order to achieve 0. So there's 2 points that you know, but of course in the middle you don't know anything, right? Okay, so let's look at this. Yeah, so we have what? From here we have to form an equation. So we cannot call 12 feet. We have to call in a form of x. Yeah, we have to call in a form of x, because remember we will have to slope, we have to plot this graph, isn't it? Yeah, this graph, we don't know this graph, how's the line going to be. So that's the reason why you have to call, like the previous lesson that we have done, we call this x and we solve for the x, yeah, so that we get an equation. Okay, so you see fy equals to 0, 240 pointing upward, half times base times height. Okay, so why is it 10x? Why is it 10x? Because this is ratio method. Yeah, 12 feet 120. So if this is 10, this is 1. Yeah, so if this is x, then this will be 10x. So half times base times height, half times base times height. So you get what? This will be a form of equation. Yeah, equals to y. You can actually plot this graph, but in order to see where is it intersecting 0, you just have to equate this with 0. If you equate with 0, you know that the intersection point is 6.93. So you know at 6.93 this thing is actually coming to a point 0. So you have 240 here, and then you have your negative 480 down here. So you just have to join the lines. Okay, so that is how it works. Okay. Okay, next, from here to here, how do we plot from here to here? Okay, Remember what I told you, when it's intersecting a 0, it will be a maximum, yeah, value which is can be negative maximum or positive maximum. You need to calculate. Okay, so if you look at this equation here, yeah, so what we have here, we have okay, so we need to form an equation, right? Okay, we need to form a equation here. We need to know whether this is going down or going up. Yeah, we are not sure, but we know that the graph will be order of 3, power of 3, because the previous one was power of 2. Yeah, because this one is power of 1. Okay, okay, let's form an equation here. So what we have here, okay, we can use the previous method that we have done, yeah, the equation method, where oh yeah, before that, let me just explain to you something very unique here that you need to observe. Let me just use, is there a moment here? No. Is there a pre-existing moment? No. So which means this graph will start with 0 and will also end with 0, and we know that the maximum is going to happen as 6.93. okay, so observe this next line. So you need to form an equation which is 240 with a distance of x. Yeah, always call x, yeah, because you know why, you want to form an equation. Yeah, if you put in a fixed value inside here, you cannot form an equation. Yeah, okay, so the triangle is at the ratio of x, and then we have 10x here. Yeah, so if we centralize this force for the triangle, it will be half times base times height, and the distance would be x over 3 from the point that you are cutting, right? This from the previous lesson. So from here we can find the equation, which is actually in the power of cube. Yeah, power of cube. Yeah, okay, so from here, from that equation that you have actually found, okay, you can actually plug in 6.93 in order to find the maximum value of 1109. Okay, that's how you solve for the question. So like, okay, let me just guide you here with the equation. Yeah, so it will be m plus half times base times height. Yeah, half times 10x. Yeah, 10x x, that will be the triangle with a distance of x over 3. Okay, and then minus with, because this is going clockwise, right? Yeah, going this side, right? Because the moment is here. Okay, we have 240 multiply with x. Okay, so this is the equation. This working is actually to find the highest maximum value. So that's all for this lesson. Yeah, I've actually solved example 7.8 and 7.9. So what I want you to do is, I want you to do some self-study. I have actually solved the difficult ones, yeah, 7.9 and 7.10. So you can just do the self-study for 7.8, yeah, and then submit it in the link below. Okay, thank you.